Hello Seahawks. Today you're going to be taking notes on rational numbers. Here are your notes page that you're going to be taking all your numbers on. And the first part just explains what a rational number is. And I talked to you about whole numbers and natural numbers and integers already. Remember, natural numbers were the numbers you naturally learned when you were little. You naturally started counting 1, 2, 3, 4, 5. Those are your natural numbers. Your whole numbers are all of your natural numbers, including now 0, because you didn't naturally start counting by 0. 0 is your whole numbers. 0, 1, 2, 3, 4, and so on. Then integers are all of the whole numbers and the opposites, so 1, 2, 3, 4, 5, and then negative 1, 2, negative 1, negative 2, negative 3, and so on. Now we're going to talk about rational numbers. Now let's just talk about for a minute, can I consider the number 1? The number 1 would be considered a natural number, a whole number, an integer. Well, it's also a rational number, okay? A rational number is a number that can be written as a ratio of two integers. Anything that can be written as a fraction is rational. That's what your definition here says. Okay, so right here it tells you this. Anything that can be written as a fraction is a rational number. So if you could write it as a fraction, it's rational. Okay, so here's examples. 4/5. Okay, that can be written as a fraction. A mixed number. Although it's a mixed number, 1 7/8, you can rewrite it as 15/8, which is a fraction. Whole numbers. Any whole number can be written over 1. So the whole number 36 can be 36 over 1. And I'm just going through these examples right here. An integer, negative 45. You can write that over 1. That makes it a fraction. It's a rational number. Any terminating decimal you can write as a fraction. Any repeating decimal can be written as a fraction. 0.6 repeating, and I talked to you about this. This should be put into your memory. Can be written as 2/3. Those are all rational numbers. So a big question is, well, what's not rational? What is irrational? Okay? An irrational number is any non-terminating decimal that does not repeat. Okay? So the number pi, although we use 3.14 for pi, we rounded that. That's technically not pi. Okay? Pi is actually an irrational number. Okay, the square root of 5. It's a big, long, crazy number. If you punched into the calculator the square root of 5, you would get a big, long, crazy decimal, a non-terminating decimal. That would be irrational. Okay, so let's talk about writing some rational numbers and converting them from a fraction to a decimal. Okay, it says to write a fraction, writing a rational number as a decimal, all you have to do is divide the numerator by the denominator. Okay, so you're basically doing long division. So for number 1, you're going to take the 5 and you're going to divide it by 8. And I don't know how well I'm going to fit all this, but we'll see. Okay, so 8 does not go into 5, so I'm going to put a 0 there, and I'm going to add a decimal. But 8 does go into 50 6 times, okay? 6 times 8 is 48, and hopefully you know how to do this long division because you're going to need to know how to do it. Okay, and 20 divided by 8 is 2. 2 times 8 is 16. Subtract there, you get 40, and 40 divided by 8 is 5. And there we go, we're finished right there. Okay, so 5/8 written as a fraction is 0.625 or 625 thousandths, if you were to say that properly. Okay, number 2, we have 3 divided by 22. Okay, so, I'm sorry, 3 over 22, but we're going to figure it out by doing 3 divided by 22. Now notice I put that negative up there because that's where I'm going to put my answer, and I don't want to forget that it's a negative number. Okay, 22. 3 does not divide by 22. Add my 0, put in the decimal there. Oops. Okay, and we have 30 divided by 22 is once. It goes in one time. Subtract that. You get 8. Okay. 80 divided by 22. It doesn't go in 4 times, so 3 times. That would be 66. We subtract there. And we get 140. And 140 divided by 22. And now this you may have to think about a little bit, but I know that it's 6 times 2. That's 12, and that's 13. Okay. And what happens here when I subtract, I get an 8 again. So what's going to happen here is my 3 6 is repeating. Okay. So my answer here is negative 0.136 repeating. It's the 3 6 is going to keep repeating. So that's my answer for number 2. Okay, and you really do need to know how to do this long division. I'm going to not do 3 and 4 on this page because it's going to be too tight. I'm going to switch that to the next page. Why don't you take a moment and try numbers 3 and 4. I know you got the whole number there, but if you could figure that out, you should be able to do that long division on your own. And remember, everything that I write, you should be writing on your paper. So I hope you have this long division on your notes. Okay, this is going to give us a little bit more room, which is nice. So for number 3, I have 2 and 2/9. Well, we know it's going to be 2 point, and then we're going to change 2/9 to a decimal. So we're going to take 2 and divide it by 9. Okay, 20 goes in 2 times. That would be 18. And I get a 2 again. If you could see now, what's going to happen is you're actually going to have a repeating 2. So it's actually 2.2 repeater. And I may have mentioned to you that we're not using repeaters anymore, but if you are asked to change a fraction to a decimal, and that's the decimal, then you're going to have to use it there. I told you I like fractions better because they're more exact, and this is an example. 2 and 2/9 gives you the exact number, where 2.2 repeating is technically not exact. Okay, and then number 4, we have negative 3 and 3/40. So I'm going to take that negative 3, and then I'm going to take the 3 and divide by 40. Okay, now on this one, oops. Okay, we have 0. And on a decimal, it's 40. 30 does not divide by 40 yet. So we have 40. 300 divided by 40. Let's see. 8 times 3 would be 32. That would be too big. So it's 7. 7 times 0. 7 times 4 is 28. And here we're going to subtract. Oops, that's right. We got 2. Okay. And 200 divided by 40. That should go in evenly 5 times, and that would be a 200. So my answer here is negative 3.075, and that's a terminating decimal. Let's talk about that for a minute. Okay, 4 is a terminating decimal. It's rational. Number 3, 2.2 repeating. It's a repeating decimal. So that would be a rational number. These are all rational numbers. Well, they all started as a fraction, so obviously they're rational. Okay, the next part we're going to do writing decimals as fractions or mixed numbers. Okay, now we're going to write decimals as fractions or mixed numbers. And the way to do this is you're going to say it properly and then write it. And you should have learned how to say these decimals properly. But if you look at number 5, we have 0.68. Okay, this is your tenths. This is your hundredths. So to say that properly, you would say 68 hundredths. And you would write that as a fraction, just as you hear it. 68 over 100. Okay, and you always have to simplify those. So 68 hundredths I know can be simplified because they're both even numbers. But it's easier. You could cut it in half if you want. And then you could simplify from there. So 68 divided by 2 would be 34, and 100 divided by 2 would be 50. And then 34/50ths is also both even numbers, so you know that could be divided by 2. 34 divided by 2 is 17, and 50 divided by 2, is 25. So 17/25 for number 5. Okay, number 6, you have a negative 0.01. To say that properly, you could say negative, and it would be 1. This is your tenths, this is your hundredths, so 1/100th, 1 and 1/100th. And that's already simplified, so you don't have to do anything more with that. You could just finish there. It's already simplified. Why don't you try number 7, 8 on your own? Negative 3.99, that would be negative 3 and 99 hundredths. So you would write that as negative 3 is your whole number, and 99 over 100. And that's already simplified. So there's your answer. And number 8, you would have 8.745. That's 8 and 745 thousandths. So you would write that as you hear it, 745 over 1,000. And then you need to simplify that. I know that 5 goes into both of them. Oops, it's thousandths. Because they end in 5 and 0. So 5 goes into 745. That would be 129 and 200. 8 and 129 over 200 would be your answer there. In this last part, we're going to be comparing and ordering numbers. And when you're comparing and ordering numbers, you can't compare a decimal to a fraction unless it's an obvious one. So in order to compare them, you need to change them all to decimals or percents to compare them. Or you could compare fractions as long as they have the same denominator, or again, if it's an obvious one. So looking at this example, we have 1400ths and 1/8. I would change 1/8 into a decimal first. Okay, so we have 0.14, which we already know, 1400ths, and we're going to change 1/8 into a decimal. If you don't know that, you'll have to do the long division. 10 divided by 8 goes in once, and you subtract there. 20 divided by 8 is 2. That would be 16. And 40 divided by 8 is 5. And then you're done there. So you have 1400ths, and you're comparing that to 125 thousandths. And 1400ths is actually greater than 125 thousandths. Okay, on the next one, these are pretty easy fractions to change to decimals. You have 1.6, and I would change them all into decimals first. 1/3, I told you, or it's a negative 1/3. You should know that one off the top of your head. That would be a 0.3 repeating. Negative 0.5. Okay, 4/3 is really 1 and 1/3, so that would be 1.3 repeating. And negative 3/2 would be negative 1 and 1/2, so negative 1.5. And now let's put them in order from least to greatest. Let's take a look at our negatives first. And remember, negatives, the larger the negative, the smaller the number. So we're going to start with negative 1.5. And then next we have negative 0.3 and negative 0.5. So that would be negative 0.5. You got to kind of think backwards on those negatives. And a negative 0.3 repeating. And now you have your positive numbers, which are nice and easy, 1.3 repeating and 1.6. And you could change those back into the original if you want, but you don't have to. And that's all we have for today. Ryan would like to do a little show for you if you want to stay tuned. Make sure you have everything written that I have written down.
Hi, everybody. Welcome to the
Ryan Show!
Today we're going to be learning about times tables. Times tables. What are times tables? Well, they are using multiplication. So, let's put a circle around that. Circle. So, multiplication is our objective today. So,
Go to the next slide.
okay, so, yeah, we just messed up for a minute, but we're okay. So, we're going to do 7,000 times, let's do 2,000. That equals 9,000.
What? 7 times 2.
That equals 14,000.
No. 14 and then you add the zeros. 6 zeros.
6 zeros? There's 6. It would equal 14 million number. So, let's X out that now since we're not using it. And so, yeah. Now let's learn about circles. Circle, circle, circle.
Pretty flat. That's why that's coming up around yours.
But, is this a circle? No! What is it, everybody? An oval! Good job. So, that is not a circle. That is not a circle. But, this... But... But... Wait. But these are, how about this? Is that a circle? No. Good. How about this? Is that a circle? No. Good job. How about... Now we're going to do... We're going to learn about tomato soup.
You have 2 more minutes.
We're going to learn about tomato soup. So, here's our bowl of our delicious tomato soup. Tomato soup. So, we have 1, 2, 3, 4, 5, 6 tomatoes. But including this little tomato right here, we have 7. So 7 tomatoes. Now we're going to do 7 plus 4. Tomatoes equals 11. But not just 11. What if we thought it was 11 elephants? Tomatoes. Let's draw a tomato because I don't have enough room to write tomatoes and I don't know how to spell it. Now we have these dots because we did it. Yay! So, thank you for watching The Ryan Show, and next time I will be back. Dun, dun. Good? Can I watch it? Wait. Wait.
Teeth.
No, my lips are too big.
Oops.
No, I like it like that.
Yeah?
Yeah.
Okay. Okay, and say
Have a good night.